Good afternoon. On behalf of the Midwest Center for Occupational Health and Safety, I welcome all of you to the National Occupational Research Agenda, or the NORA seminar this afternoon. My name is Gurumurthy Ramachandran, and I'm a faculty member in the Midwest Center. The seminar series is designed to raise awareness of new social, demographic, technological, or economic trends shaping the experience of work and influencing worker health and safety. I have a few brief announcements, and then we can get started with the real star of today's show. The seminar is complemented by a poster session where ERC faculty and students present their latest findings on NORA-related research. And so after today's seminar presentation, I welcome all of you to attend the poster session and also enjoy the refreshments that we have over there. You all have in front of you a couple of pieces of paper. There is a survey that we ask that you fill out after today's program is over. There is also, I think, a photo release form that we ask that you sign. And at the end of Dr. Hewett's presentation, we'll have a question and answer session. And we are tape recording, or audio and video recording today's session. So if you can wait till somebody with a mic comes up to you and then ask the question, we'll really appreciate it. The annual seminar series has been very popular. We've had it for several years now, and we've had a unbroken series of very distinguished speakers. And I'm glad to report that we're going to maintain that record by having Dr. Hewett speak to us today. He is one of the preeminent leaders in exposure assessment and occupational hygiene in general. He worked for about 25 years in NIOSH's Division of Respiratory Disease Studies. He's a past chair of the Exposure Assessment Strategies Committee of the American Industrial Hygiene Association, as well as a fellow of the AIHA. He's the 2007 winner of the Edward Bayer Technical Achievement Award, and he has several other achievements to his name, which I'll not get into. We know him best, or I know him best as the person who's been developing all sorts of very, very useful statistical software packages, very user-friendly, that he has been sort of going around evangelizing and bringing statistics to the industrial hygiene community and asking the IH community to actually use them. But today he's not going to be talking about exposure assessment. He'll be talking about a very important aspect of occupational health policy. An important goal for our Midwest Center and the seminar series is to address global issues that have both national and regional implications, and the REACH initiative certainly fits that bill. As Dr. Hewett contends, the European Union REACH initiative has the potential to radically change the practice of environmental health and safety worldwide. And so with that, I'll let Dr. Hewett take the podium. Please welcome Dr. Hewett.
Thanks, Ram. Well, until today, an unbroken record of good speakers. Well, let's start. I'm going to cover these topics. You have handouts before you, so we'll just proceed. Well, first, I would like to pretty much try to explain where I think we are today, and then talk about REACH and where it might lead us in the future. So we'll look at regulatory requirements, AIHA exposure assessment model, and a few other things, ending with REACH and then going on into it. So regulatory requirements. What do we have to guide us in our industrial hygiene endeavors. Well, OSHA has managed to promulgate a whopping 17 single substance standards in over 30 years. Not terribly impressive. There's no requirements for exposure monitoring or medical surveillance for all the substances in tables Z1, Z2, and Z3. Those are the 400 substances or standards that were adopted in 1972 that were already in existence, consensus standards, so on and so forth. We basically have little to no progress promulgating health-based exposure limits. So other agencies, such as Department of Energy, have grabbed the bull by the horns and developed their own standards. We have a 1999 beryllium standard for contractors working for the Department of Energy. DOE says, you will develop a statistically based monitoring strategy and adequately characterize exposures. Okay, great. They reference in their preamble to that particular standard the AIHA exposure assessment model. So they suggest that be a basis for designing a statistically based strategy. And a good deal of that is also covered in this new regulation 10 CFR Part 851 on worker safety and health. Well, it's worth reading if you haven't already. So we have those government regulations. NIOSH is proposing or has proposed recently to revise the 77 Sampling Strategies Manual to give us more guidance on doing the exposure surveillance for all those tables Z1, Z2, and Z3 substances, in addition to other substances for which there are no government exposure limits. NIOSH in 77 gave us this guidance in the Sampling Strategies Manual that basically at that time took an inspector-type mentality or approach and asked the question, are we in compliance with the exposure limit or the PEL permissible exposure limit today? And so not asking the question, are we in compliance the majority of the time? It focused on collecting a single measurement across a single shift and all the various ways one can collect it. And here's a chart out of that 77 manual. Full shift sampling, consecutive partial shift samples, partial shift samples, grab samples, all the various ways you can estimate a full shift exposure limit. And then asked, well, is that measurement, our point estimate, significantly above the OEL, or the permissible exposure limit? If the lower confidence limit is above that standard, an OSHA inspector can issue a citation. So fairly limited in scope, that manual. Then in 2006, we got the third edition of the AIHA Exposure Assessment and Management Model. There were two other editions, 91, 98, which basically asked the question, are we in compliance with all OELs, all exposure limits every day? We have the flow chart out of that manual. What I'm trying to do is lay the groundwork before we start talking about REACH. So we have that flow chart, which gives us a structure for designing exposure assessment strategies. Eventually we have to reach a decision exposures are acceptable or unacceptable. And if exposures are acceptable, how acceptable are they? A category 0, a category 1, 2, or 3. Are exposures highly controlled or just barely controlled? If exposures are unacceptable, how unacceptable are they? Just barely out of compliance or unacceptable? Or are we several multiples above the OEL so that we have to institute immediate process shutdown and so on and so forth? Now, the AIHA model is based upon these exposure categories. Categories 0 through 4, when some of us add 5, we've added that to the model for egregiously bad exposure scenarios. So it's basically this situation where we pick an exposure parameter, such as the 95th percentile. We find some basis for believing that it's in category 0, 1, 2, 3, or 4. And by that we mean, for category 4, for example, we believe that the true 95th percentile is greater than 100% of the exposure limit. That would be a category 4. If we believe it's between 50 and 100%, as a category 3, 10 and 50, 1 and 10, and less than 1% for de minimis exposures. And then how confident are we in that belief? High, medium, and low. Now we can take our data, we can do some statistics, we can throw in professional judgment, we can calculate some relevant statistics such as geometric mean GSD, which then leads us to the 95th percentile or the exceedance fraction. We do a goodness of fit evaluation to assure ourselves that the data are reasonably log normally distributed, therefore our statistics will have reasonable predictive value. And then we come to a final decision that exposures are category 0, 1, 2, 3, or 4, and those final decisions or final ratings lead to actions. If it's a category 4, do something. use respirators, start implementing engineering controls. If it's Category 3, exposure surveillance, medical surveillance, work practice analysis. If it's Category 2, chemical-specific hazard communication. Category 1, Category 0, little or no other action. So it's not so important to know exactly what the true 95th percentile is or the true geometric mean of GSD. You will never, ever know them. What is important is making the right category decision, because that leads to actions, and you want the actions to be consistent with risk. So that's the AIHA model. Another thing that has been developed over the past number of years is the concept of performance-based exposure assessment strategies. And I've written a technical report on this, and there's some EPA information. Basically, this is a way of designing an exposure assessment strategy that actually does what you want it to do. Now, if exposures are poorly controlled, wouldn't you want your strategy, your corporate strategy, to actually detect that? Let's say you go into a doctor's office, you take a test. If you actually have that disease that you don't really want to have, but if you actually have it, you want that test to detect it, don't you? Okay, same thing with an exposure assessment strategy. An exposure assessment strategy should be designed to detect poorly controlled work environments. So here are some methods for doing that. The EPA has put together some methods for testing land, building, and equipment that has been previously contaminated and has been remediated, and so you're trying to test it to see if it can be released for public use. So similar concepts. In 1981, a paper was published showing how the government strategy for collecting exposure measurements, rather what government OSHA requires of companies, is a very poor strategy. And I don't have time to go into that particular strategy, but this operating characteristic curve or performance curve shows us how bad that strategy is. Now, OSHA regulations for benzene, acrylonitrile, cotton dust, asbestos, all the other single substance standards has this type of strategy built into it, where you collect one measurement. If it's less than the action limit, you declare victory. Exposures are acceptable. If any measurements above the limit, exposures are unacceptable. If the first measurement between the action limit and the exposure limit, then you keep collecting measurements till you get 2 in a row less than the action limit. Well, if you truly have 25% overexposures, and the true geometric standard deviation is around 2, then 50% of the time you will falsely declare exposures acceptable. This strategy has a poor power to detect, a poorly controlled work environment. So here might be an ideal performance curve. Using the AIHA scheme, if we have a true Category 4 exposure where the true 95th percentile is greater than the limit, where the limit is 1, that the strategy detects that almost all the time. That is, there is a low probability of deciding exposures are acceptable. If you have a true Category 0, 1, or 2, where the true 95th is less than 50% of the OEL, the strategy should declare or allow you to conclude that exposures are acceptable nearly 100% of the time. And then for a Category 3, you're somewhere in between. So you want a strategy that has a high power to detect a Category 4 exposure profile. That's what the AIHA model is aimed towards. So I have a paper. What do I have? A paper on this that's downloadable from a website. And I even wrote some software, free software, where you can simulate strategies and improve those strategies and test it through developing performance curves through computer simulation. So a little bit of a plug, but we'll ignore that. The one thing that has been developed in the last 10 or so years are Bayesian methods. There's been a number of papers. Ram Ramachandran has published 3 papers. John Cherry from the Institute of Occupational Medicine. I think this is a French or a Swedish group that published recently in the Institute of the International Occupational Hygiene Association Proceedings. And then we have a paper, several of us, that was recently published, all on applying Bayesian methods to decision-making or exposure assessment. And these two are aimed at REACH, actually, evaluating exposure scenarios under REACH. So the goal here is to factor past data, modeling information if you have it, and professional judgment into an analysis to where you come to a decision that exposures are acceptable or unacceptable. Now, probably the finest paper ever written on this concept is this one by Dr. Paul Hewett, Perry Logan, John Mulhausen. This fellow, I can't Ram Chandran, whoever he is, and Dr. Sudipto Banerjee. And we developed this method to calculate the probability that the true exposure profile falls within one of those AIHA categories. Now, I'm bringing this up because this can be applied to REACH later on. I'll mention that later, I hope. So BDA, this Bayesian decision analysis, combines professional judgment and the always limited data sets that we have as industrial hygienists into a decision-making process that we hope eventually, or it can be considered objective and transparent. So basically it works like this. Let's say we have an OEL, it's 1 part per million. We collect 3 measurements, 0.2, 0.05, and 0.1. We can calculate the geometric mean and the GSD. Now here we have a map. We call this parameter space. Geometric mean, GSD on the X and Y axes. Now this can be divided up into those AIHA categories, 0 through 4. All combinations of geometric mean and GSD in this zone is a category 4 exposure. That is, the true 95th percentile is greater than the limit. In this zone, the 95th percentiles are between half and 100% of the limit, between 10 and 50%, 1 and 10%, and less than 1%. So what we're trying to do is, with our data, determine which category are we in. And then that category determination then leads to action. So we want those actions to be consistent with the level of risk in the workplace. So here's our point estimate. Each point in this chart refers to a unique exposure profile. But there's variability in the geometric mean, an order of magnitude. There's variability in the GSD, an order of magnitude, which gives us this huge cloud of uncertainty. A point estimate says category 2, but could it be category 3? It could be category 4, given this cloud of uncertainty. Bayesian analysis allows us to estimate the probability that the data came from each of those 5 categories. Not only that, we can throw in professional judgment. We have a prior, likelihood, and posterior decision chart. Now, if you go to that article, it explains everything and all will be revealed. But, we believe that this is a method that can be used for making decisions with limited data that allows you to factor in professional judgment. Another thing that's happened in the past 10 or so years is the rise of control banding, or expert systems. So control banding refers to an expert system for doing a quick and dirty risk assessment for substances both with and without OELs. It's designed for the owners of small and medium-sized businesses, or SMEs, small and medium-sized enterprises. There's 2 versions, a United Kingdom version, which was the original, and an internationalized version that was commissioned from the UK by the ILO. Both are available free. Those are the websites I encourage you to visit. Now, the UK version is based upon risk phrases and hazard groups. So every material safety data sheet in the European Union has risk phrases. And the risk phrases lead to hazard groups. Now we have A, B, C, and D. There's an E and an S. I won't explain those. But low toxicity to high toxicity. So R20 refers to something that is toxic by inhalation. I think R23 refers to something that is very toxic and then highly toxic by inhalation. So depending upon the R phrase, you have a different hazard group rating. Now, I just want to point this out. This is interesting. A substance that has no R phrase is automatically considered, what does that say? Oh, yeah, substances that do not have R phrases, I think it's automatically considered a hazard group A, the least toxic. Okay, so how this works. The R phrase leads to a hazard group. The hazard group leads to an exposure limit. Hazard group A, exposures should not exceed 10 milligrams per cubic meter for particulates or 500 for vapors. If it's hazard group B, you drop that down an order of magnitude. The maximum is 1 milligram and 50 parts per million, so on and so forth. To get to hazard group D, exposure should be less than 10 micrograms per cubic meter or less than 0.5 parts per million. So we have 4 exposure limits for all substances as long as they can be categorized as hazard group A, B, C, and D. Makes it simple, doesn't it, people? 4. Wouldn't you be happy with only 4 exposure limits? Okay. Do we have any industrial hygienists in the audience? Okay. Now here's how it works. We do we evaluate the health hazard. The R phrase leads to the hazard group, so that leads us to an exposure limit. Then we do a quick and dirty exposure potential assessment using only these determinants of exposure: quantity, dustiness, and current control. And based upon that, the question is the current control stringent enough to reduce exposures below those 4 exposure limits I mentioned? If not, upgrade the controls. So this is the basis of that expert system. For example, if we have a medium dustiness substance, medium quantities such as kilograms, and it's a hazard group C substance, then we need a level 3 or a containment type engineering control. And you can see if it was hazard group B, we would only need a local exhaust ventilation control. That's a series 200, and a series 100 would be just general dilution. So you can get almost all of your answers for exposure assessment out of this chart. This is the basis for that expert system. And it also leads to the use of, or the introduction of these control guidance sheets. So here we have for mixing of liquids. This is a series 300 or containment type process. So it tells the small and medium-sized enterprise operator that your process or equipment should look something like this, completely contained. If it's a series 200 for mixing, it should look something like this, where there can be access to the liquid inside. So it gives us some good guidance. Now, this methodology has been critiqued and reviewed recently by both the AIHA and the ACGIH. Both of these publications are available. And I was a co-author of the Control Banding Issues and Opportunities monograph from the ACGIH, and I encourage reading both of them. Ours, I think, was a more critical review of control banding. So control banding is going to be around for some time, but we feel it's important to recognize its limitations. It's an expert system, so how good is it? Another thing that's happening is global harmonization. Common safety data sheet formats, common hazard phrase terminology, common warning signs, so on and so forth. And the U.S. is moving in this direction. Now that leads us, I think, on slide 29 or so, finally to REACH, the topic of today's presentation. So REACH, what is it? Where did it come from? Why? What's it going to involve? So it was recognized in the European Union that we have very little information for the vast majority of chemicals, vast majority of mixtures. So for only a small data subset of all the possible substances do we have adequate databases regarding health effects, so on and so forth. A white paper came out in 2001, and this is when I first became aware of what might be happening in Europe. So I've been watching this since 2001. I'm not an expert in REACH. I want to point that out right now. I do no consulting, none whatsoever. I am simply a disinterested observer from across the pond. Well, I am disinterested, yes. Okay, I am an observer, though, so I think it's a fascinating experiment, and I hope you agree with me. So this white paper came out, I downloaded the PDF and printed it off, and I was amazed. So they talk about a strategy for future chemicals policy. EU is the world's largest producer of chemicals, chemical industry's third largest enterprise in Europe, 5 million workers, so on and so forth, but there's this lack of knowledge regarding the impact of chemicals to workers, consumers, and the environment. And even in Europe, with as far fewer lawyers as they have, they still have this slow pace of legislative action. They announced that any policy should embody or incorporate the precautionary principle, where when there's scientific uncertainty, that decision-making must be based upon precaution in order to prevent damage to human health and the environment. The policy, whatever it should be, should encourage substitution, technical innovation, and development of safer chemicals. So these were outlined in that initial statement. That 2001 document is still available, and I encourage you to download it and look at it. Major issues, we have this lack of knowledge. The burden is on the government to do all the necessary risk assessments. That's the same thing here in the United States. Almost in the United States, a substance is non-toxic until the government, i.e. the taxpayer, proves beyond a shadow of a doubt that it is toxic to workers, to the environment, to public. So now that they've recognized the same thing in Europe. Now, risk assessment process, they said, is slow, expensive, and subject to challenge by industry. Okay, so we have those issues as well. These are their objectives. Protect human health, work environment. Maintain competitiveness of the EU chemical industry, so on and so forth. Increase transparency regarding all these decisions regarding health effect, environmental fate, and all that. And so these are their goals. Proposed solution, make industry responsible for everything. Now, this is a key factor of REACH. This is shifting the burden of responsibility from the government and taxpayers to industry. So the Commission proposes to shift the responsibility to enterprises, industry, to major consumers and major users of chemicals and mixtures for generating and assessing the data, assessing the risk of the use of the substances. And so they outline this new process, REACH, standing for Registration, Evaluation, and Authorization of Chemicals. High hopes. The proposed EU regulations will require producers and importers to register and develop information. Eventually there's going to be this high level of protection of human health and the environment, and at some point down the road there's going to be this recognition that they have saved billions and billions of euros in occupational care costs, environmental issues, and in better public health. So how does it work? There's all these components, so let's go through them. It applies to all substances manufactured and imported, so American manufacturers doing business in Europe have to pay attention to this. Both marketed and intermediate substances, I think pure substances and in preparation, even articles that may have residual monomer or chemical inside them. There are exceptions: radioactive substances, food, waste, some defense-related materials, and from what I understand, the last time I gave this presentation, I think pharmaceutical APIs might be outside the scope of this, perhaps covered by other regulations. So registration: a substance cannot be manufactured or imported if it is not registered. Now there's a deadline for registration. Registration is coming up. The deadline is December 31st, I believe, this year. All substances have to be registered, or else you cannot, pre-registered rather. A manufacturer and a reporter must provide a complete registration dossier eventually to the agency. So you can pre-register by the end of the year, but eventually you're going to have a complete registration dossier. That's going to consist of a technical dossier, a chemical safety report. What else do we have? It's hard to read from the side here. Oh, registrants are encouraged to join in consortia. That is, individual companies can submit a registration dossier if they want to, but the goal is for companies manufacturing or marketing the same substance to develop consortia and develop single registration dossiers. And some percentage of them will be undergoing a simple electronic check, and others will be undergoing a complete check. Okay, so right now it applies to substances that can be released to articles, and when a substance is present above 0.1% by weight in an article, I believe. Okay, so the technical dossier: properties, uses of the chemical, classification. Is it a carcinogen, mutagen, or reproductive hazard? Is it something that is persistent, bioaccumulative, or toxic, or very persistent and very bioaccumulative? Whatever that means. Now, the toxicologists love this. They understand these terms. But to me, it just means that they're trying to classify the substance in these various categories, and it's got to provide guidance for safe use. So the industry, the companies, have to tell the consumer, the users of these chemicals, how to use them safely. The chemical safety report documents the hazards, has this PBT, or very persistent and bioaccumulative assessment, outlines exposure scenarios. The producers and users of these chemicals have to identify the major use scenarios and provide information on how they can be used safely. So let's see, what do we have here? Exposure scenarios for substances that are dangerous or persistent and bioaccumulative, covers all identified uses, specifies risk management measures and operational conditions, and the goal is adequate control of risk, although adequate control is not defined specifically. So the goal is to control risk in an adequate fashion. We have various timelines. Pre-registration ends the end of December this year, and pre-registration basically at this point means you go onto a website, you download a couple forms, you fill them out, and you send them back in. It's basically your announcement that you're intending to continue selling the substance in Europe, and that eventually you will get around to filling out the complete dossier. And then for substances that, completely new substances, they have to go through the entire treatment, fill out the complete dossier, chemical safety report, and the technical report. But we have this gradation here. 1 metric ton per year for the CMRs, or greater than 100 tons per year for substances toxic to the aquatic environment, and other criteria have other deadlines. We move down to greater than 100 tons per year for virtually anything, and then at some point in the future, anything that's brought into the European Union in quantities of greater than 1 ton per year will have to be fully registered. So we have these timelines, and eventually everything is going to be registered that's marketed in Europe. So we have this pre-registration period right at the moment. One thing they're encouraging is to share vertebrate animal testing. They want to eliminate mammalian testing as much as possible. Downstream users, let's see, what do we have? Oh, there's some extension for downstream users. And what do we have? A substance information exchange forum. They're trying to encourage people to pull together, limit the amount of experimentation that goes on, animal testing, and share the data. Okay. Then in the supply chain, the material safety data sheets, which they're just simply going to call safety data sheets, provide information to the users of, or well, users and importers and distributors and downstream users. Let's see. It's recognized that the material safety data sheets may be of poor quality at this particular initially, but over time they're expected to improve. And what they mean by that is that you're going to have safety data sheets developed by different companies and different consortia perhaps that may have different recommendations, but eventually over time they expect the safety data sheets to be high quality. I think that's what I said in the last part of this. It's hard to read this slide, this screen from the side, excuse me. Okay, downstream users. Downstream users are supposed to communicate with their suppliers, and if they have uses that aren't covered, that haven't been identified, they're supposed to bring them to the attention of their suppliers and work together to recommend appropriate controls and use of the chemical in those situations. If something is proprietary, let's see. Okay, if something's proprietary or confidential, the downstream user is responsible for developing that chemical safety assessment. And a downstream user can propose testing to the supplier if they feel that the chemical safety assessment is incomplete and they have scenarios that need evaluating. Okay, what else do we have? Evaluation of these dossiers. Some 5% are going to undergo a simple compliance check. There's going to be some kind of testing protocol. Testing protocol check. They're trying to prevent unnecessary animal testing. And if necessary, they can request additional information from industry. But again, it's industry that has to provide this information. And there'll be some prioritization of substances for further evaluation. Now, registration is one thing, but authorization may be required for certain substances, those that are carcinogenic, mutagenic, or toxic for reproductive issues. You have the persistent and bioaccumulative chemicals. These may require authorization. If the scientific evidence suggests a serious effect, that will be the case. And the agency involved in this, which I'll mention later, will publish a list of such substances. And authorization is going to be granted if the risk can be controlled and the benefits outweigh the risk. But it's up to industry to demonstrate that this is indeed the case. Now, there may be situations where there's restrictions, where the risk is unacceptable to human health or environmental. And so there may be restrictions on the use or manufacture of a substance. And if necessary, a substance can be prohibitive, such as asbestos. And there can be proposals for restrictions to the agency from other interested parties. Now, this is the agency that's going to handle everything, the European Chemicals Agencies. This is a shot from their website. There's the address, and virtually all the information that you need for REACH is available through this website. They're developing a huge, you might imagine, they're developing a huge bureaucracy to handle all of this information that's going to be flowing into this system. And all the information is going to be publicly available. So you can download it and view it. Classification and handling. We have hazard classifications. We've seen these. CMR, carcinogenic, mutagenic, reproductive hazards. We have risk phrases. They're going to continue using risk phrases until they phase into fully adopting the global harmonization system. Well, labeling by, this is just what's going to be part of the classification system. Eventually, they're going to be this harmonization of hazard classifications for the same substance. So you can imagine material safety data sheets having different hazard groups for the same substance. Eventually, it's all going to come together, they believe, in the future as we gain experience with this. Access to information, all non-confidential information will be publicly available. Costs and benefits. In Europe, they're bringing together a large number of regulations into one system. They're hoping to close the knowledge gap on those 30,000 plus substances that are used and provide incentives to industry to develop safer substances. Benefits, we're going to have public health, occupational health benefits, obviously, decreased risks of environmental diseases, occupational related diseases. This authorization of highly toxic substances and restriction of substances that are even more toxic. Over a 30-year period, they're expecting a decreased level of disease and savings of billions of euros. So they estimate there's going to be a several billion euro direct cost to manufacturers and importers right now, but downstream they expect these gains. So we have a new lexicon with REACH: manufacturer versus importer, producer versus and importer and supplier, distributor, downstream users, chemical safety assessment. And this is going to be a complete assessment of all the risks arising from the manufacture and or use of a substance. The chemical safety report, documenting and recording all the information. I think there was a sentence left off here. It's in the version I have on my computer, but I'm sorry it's not on this one. Okay, the chemical safety data sheet, conditions for safe use, all of these are going to be part of our new dictionary under REACH. Conditions for safe use, risk management measures, all the operational conditions that are necessary for the safe use of a particular substance. Now, as an industrial hygienist, this is one of the features of REACH that appeals to me and interests me. The development of exposure scenarios. So an exposure scenario is going to be a set of conditions that describe how a substance is manufactured or used. We have what else? The process is going to be described, operational conditions, risk management measures. Now these are what the companies or consortia have to develop. Risk management measures regarding the process, personal protective equipment, personal hygiene, so on and so forth. There's various types of risk assessments or exposure assessments, Tier 1, Tier 2 approaches, where you do a first cut and a second cut, and they have recommendations for the types of exposure assessments that can be done. But using control banding techniques, for example, for Tier 1, Tier 2, you may have to go to modeling or quantitative exposure assessments. But the point is that industry is now responsible for identifying the exposure scenarios and how the substances can be used safely. And that is a tremendous departure from how we do it from here in the United States. The other aspect of REACH that has fascinated me are the derived no effect levels. Companies, consortia, industry now has to recommend exposure limits. Now, how many have heard of the ACGH TLVs? How many are aware that the TLV committee frequently gets sued by industry here in the United States? Now, why is that? It's because industry does not like the values that the TLV committee comes up with. Now here, the burden of proof is completely shifted. Companies have to come up with exposure limits, and this is the basic exposure limit. It can be more sophisticated than this, a derived no effect level. This is the formula that the AIHA WHEEL Committee, Workplace Environmental Exposure Limit Committee, uses to set wheels. How many, you're all familiar with wheels. Basically, if you have a no L or low L or a lowest observed adverse effect level or a no observed adverse effect level, you pop that into your equation. You have all these adjustment factors from extrapolating from high dose to low dose, short term to long term, from animal species to human, and you end up with an overall adjustment factor, and out pops a derived no effect level or an exposure limit. Now, companies are now going to be required to develop these. and this is part of the entire process that so fascinates me, the burden of proof has been shifted entirely to industry to come up with identifying exposure issues, how to safely work under those conditions, and the exposure limits that should be used to determine are you managing risk appropriately. There's lots of criticism, both in Europe and in the United States. The American Chemistry Council does not believe that REACH will do what it's supposed to do, that it's unworkable, impractical, and costly. They've proposed alternatives. They've developed what they call the strategic approach for international chemicals management. There is some concern that REACH is simply a European initiative to keep the U.S. out of their market. Oddly enough, Europe thought TSCA was an attempt in the United States to keep Europe out of the American market. So what goes around, so to speak. Okay, so there is criticism. Now, as industrial hygienists, what are the opportunities for us? Now, you notice I have a bunch of question marks here because this is the part where we get to audience participation. Now, none of you are allowed to leave the room until you've participated. So what are the opportunities for us EHS professionals under REACH? If you're working for a company that's going to be doing business or does business in Europe, what are the opportunities? Identifying the exposure scenarios, perhaps? How is the substance manufactured? How will it be used? How will equipment be maintained? How can the substance, when spent, be safely disposed of? What are the exposures in the environment? Job security. Several years ago, there was a British Occupational Hygiene conference. I believe that, well, it was 2 or 3 years ago, where they asked the question, are industrial hygienists, or occupational hygienists as they call them in the UK, positioned to provide services under REACH? And the conclusion was yes. So there are opportunities for us EHS professionals. So developing those exposure scenarios, determining that if you do this in this fashion, using these work practices, this type of equipment, you will be less than the derived no effect level, or you will be less than the health-based exposure limit that has been derived by the consortia that you work for. Also, downstream users, if you use the recommended procedures, you're going to have to do some exposure monitoring, some exposure assessments to assure yourselves, your company, that you are indeed managing risk relative to that DNEL. So I think there's lots of opportunities, obviously opportunities for toxicologists and epidemiologists, and for those that can write, string together 3 coherent thoughts into a sentence or a paragraph, because you have to come up with the description of the exposure scenarios and the recommendations, so on and so forth. Anybody see any other opportunities? Yes, ma'am. Well, that's what they're encouraging. They're obviously encouraging the substitution of safer chemicals, the elimination of highly toxic chemicals, and they feel that this will actually spur innovation. So I think there are a number of opportunities. Anybody see any other opportunities that we failed to mention?
Sorry, we can't hear you.
Well, companies that jump on it quickly will have a better chance at gaining market share in Europe.
One would think so. Yeah, so those are on board early, do their pre-registration, develop consortia, leverage resources, and they're talking, they're trying to component of REACH, and eventually, you can imagine companies coming together and identifying that they have common unit operations and leverage their resources in characterizing those operations, come up with common sets of recommendations. And I think it's a good thing for occupational health and industrial hygiene, so on and so forth. I think it's a grand experiment, and we'll see where it turns out, where it goes. So what's the potential impact? Well, we have these changes from afar, potential impact here in the United States. Well, we have changes forced from afar, global harmonization, REACH, this control banding, so on and so forth. So REACH, we're going to have to develop these consortia, develop occupational environmental data, recommend safe OELs, and that's one of the most fascinating parts of this. We've had, I don't know how many hearings on Capitol Hill where industry complains about the TOV committee or complains about exposure limits proposals from OSHA, so on and so forth. Well, now the burden of proof is completely on industry to come up with these exposure limits. Identify these major use scenarios, recommend control strategies to eliminate risk. Well, if a company is going to recommend a strategy, if you're using this chemical with this type of unit operation, these types of controls, and if you do it this way, you are safe. Well, the company better know what it's talking about if downstream users are going to take that advice and run with it. So how do we validate that an exposure scenario is appropriate, is where exposures are managed appropriately for each of the exposure scenarios? You can use modeling, you can quantitative exposure assessments, Bayesian-based methods, such as what we mentioned earlier with Bayesian decision analysis and the other methodologies that have been developed in Europe by John Cherry at the Institute of Occupational Medicine, for example. So we have REACH, and what else is going to go on here? Oh, okay, another thing I want to mention. How it's going to affect us here in the United States is that if you have companies or consortia that market a substance or chemical in Europe that has no exposure limit here in the United States, but in Europe they're recommending an exposure limit and they're recommending how it can be used safely, that information is going to affect us here in the United States because they're going to have to recommend the same thing here. You can't say in the United States there's no exposure limit, therefore in the material safety data sheet simply use it with caution and avoid high concentrations. Well, what does that mean? That's what you see in material safety data sheets. But in Europe, their material safety data sheet says, here's the exposure limit and here's what you've got to do to keep yourself safe. You can't have two sets of recommendations. The American lawyers will make sure that eventually those criteria are applied here in the United States as well. Now, those control banding principles I mentioned earlier, that expert system has been proposed as a way to help guide the selection of tentative OELs and recommend control strategies. So that's why I introduced it earlier. So it could be used perhaps as a first tier or first cut assessment under REACH. Now, control banding schemes run amok. We're going to have them for generic substances. That's what we've already seen, the UK and the ILO control banding schemes. But it is proposed to have control banding schemes for ergonomics, safety, the environment, industry-specific, and these already exist in the United Kingdom. Control banding schemes for printing operations, construction industry, quarries, so on and so forth, substance-specific control banding schemes. This is an initiative in Europe that will filter over here because we're going to be using and borrowing those materials. So I believe that there's going to be this shift in the state of the art. The U.S. has led the state of the art in occupational health for probably 40 or so years. Other countries have adopted our TOVs. Other countries have adopted our ACGIH guidelines or recommendations. Other countries have taken our AIHA recommendations for exposure assessment and incorporated it into their own guidelines. But now I think we're going to see a shift that things are going to happen in the EU. We're going to have OELs derived or set for substances for which we have no exposure limits. They're going to identify use scenarios and the proper control strategies, and we will be borrowing those. So there's going to be this convergence. At one time it was the EU moving more towards the US. I believe in the future we're going to be using a lot of what's developed in the European Union. And then other countries move in both our directions. So there's going to be this convergence. We'll be one large, happy environmental health and safety family worldwide. That's my dream. So there we go. That's my spin on REACH. I've just been an interested observer of both control banding and REACH over these years and have developed these presentations simply to have something to do and visit fine cities and bring good weather to other people. So do we have any questions? Yes, ma'am. Microphone?
When you talk about the industry coming up with its own limits, do you think that that's going to be sort of the fox guarding the hen house? Well, here, I mean, if they have to come up with their own limits, just
Well, that's quite possible. Okay, but for a substance for which there is no exposure limit, virtually any number is better than where we are. Okay. Now, if you have different numbers by different consortia, different companies, there's going to have to be a resolution of that. And what the European Union is saying is that it shouldn't be the taxpayer and the government to come up with that resolution. And eventually they will work it out. And if the EU says there's insufficient data to support that particular DNEL, then they can require additional data to be collected. But it's going to be on the part of it's going to be by industry rather than government. But yes, I mean, they recognize there is going to be poor quality in the DNELs, the control strategies for exposure scenarios, the identification of exposure scenarios. But the thing that they're doing in Europe, you have to recognize, is they are taking the long view. They are not taking the view to December when we elect another president. They're taking the view 10, 15, 20, 30 years down the road. And over a period of time, there is going to be this sorting out and winnowing out of all the bad information so that we're left with good environmental, occupational information and exposure limits for both occupational and public exposures. So the answer is yes, there's going to be a lot of lousy information to start with, but eventually it's going to converge to good, solid, defensible information. That's my prediction. Ask me again in 20 years.
Paul, what will happen with the standards that are promulgated under the EU member states, the existing standards like with the Health and Safety Executive and that sort of thing? Is there some sort of phase out? Will they still exist for a period of time?
Well, you know, that's a good question. Now, I believe there are something like 30 or so EU exposure limits at this point. It's a small list. Vinyl chloride, big, highly toxic substances. And it's taken them many years just to get that small list together. So they're doing just as poorly as our OSHA. Now, my understanding is if you have health-based standards that have, that are justified, valid, that they can serve as your exposure limit. So, you're not going to have DNELs replacing good, solid health-based limits based upon good epidemiology. I think, is that an answer to your question?
I don't know about all the European countries, but I know in the UK and in Germany there are existing lists very similar to our PELs and TLVs. Mm-hmm. Is there some mechanism as these, I forgot already what the standards are called under REACH.
DNELs.
As the DNELs are come out, will they somehow supplant the chemical exposure standards that the member states' government agencies have already promulgated?
Well, I think that's entirely possible. Now, first answer to that question, I don't know. Second answer, I'll guess. The UK limits were based upon, I think, the 88 list of TLVs, and few of those have been changed. In fact, what they've done is jettisoned or gotten rid of many of the TLVs that they adopted. If a company or consortia comes out with a DNEL that's lower than that, that company or consortia are saying, we don't believe that's a valid number, that you should control exposures to an even lower level. I don't see that that's an issue. It's certainly going to be an issue for anybody that tries to meet that level. But now, on the other hand, if they came out with exposure limits that are greater than existing company level, country exposure limits, then there can be an issue there. I don't know how that's going to work out. But one thing to recognize, this is one huge grand experiment. So look at it with a sense of humor. There's going to be one whale of a bureaucracy developed here. There's going to be bottlenecks. There's going to be software issues, upload issues, download issues. It's going to be fascinating to see how this works out. And it's not us. We're across the pond observing it. We're simply going to benefit from the information once it gets sorted out, quite frankly. The rest of the world's benefited for a long time for a lot of our hard work, quite frankly. And now maybe we're getting something back. Yes, ma'am. the question is, you're curious about enforcement.
Of this, yeah,
Well,
of REACH.
well, my understanding is they're still working everything out. They don't know what the penalties will be. They don't know how, are there going to be inspectors? How will this be enforced? And there's some projections that it's going to be laxly enforced or not well enforced, and people can slip under the radar screen. I have no idea what the penalties are going to be. But there's, if this was certainly the United States, the penalties would be toxic tort lawsuits rather than fear of OSHA fines. That's what drives, in my view, that's what drives EHS in the United States today. Less OSHA and less EPA sanctions and more fear of a poor company reputation and toxic tort lawsuits.
Thank you.
Paul,
Chuck?
am I on here? I've recently seen some text that said you do not have to derive a DNAIL. This is an occupational DNAIL. If there is an EU DNAIL that's been adopted into law. I haven't tracked that down very far yet because we've been doing a lot of derivations.
Now, is that an EU-wide or a country-specific?
See, that's another thing I have not been able to discern yet either. And the other thing is that there's not simply one DNAIL. For a single substance, there's either 9 or 12 DNAILs.
Well, you can have for aquatic environments, right?
No, let's talk about human health.
Okay.
There's the worker that you mentioned, but then there's the professional applicator, the skilled trades, and then there's a consumer. And then for each of those three categories, you have to do long-term inhalation, you have to do chronic and acute dermal, and then for consumer, you have to do oral. So it's 9 or 12 DNAILs.
So it's worse than we thought, isn't it?
Pardon?
Yeah, it's worse than we thought.
It's worse than we thought.
See, now, Chuck's working for 3M, and 3M sells 1 or 2 products in Europe. and so Chuck's very involved in trying to figure out how 3M can register all their products.
Because I work with the toxicologists, I don't have to derive the DNAILs, but I've talked considerably with them. And they said there's very little latitude once you enter the DNAIL process. You pick the best study. And then you start applying the factors, and you're pretty much locked in. And what we found, we're studying 2 substances, and one of them is fairly common, cyclohexane. We found that the cyclohexane DNAIL for consumers is 2 parts per million. For workers, it's 4.3 parts per million. And I think the worker OEL in the U.S., I think the TLB is 100, if I'm not mistaken. So they're low.
Okay, but I think a point to be made here, though, is that, with the DNAILs, you're supposed, as I understand it, you're supposed to pick the best study, but you're also supposed to look at the most serious toxic endpoint as well. Okay, so under REACH, if companies don't like the data that they plug into the DNAIL formula, guess who's responsible for developing better data? The companies.
And you mentioned the CEIFs, and that's where the CEIFs will come in. If there's insufficient data, then the European Union is going to put the companies together. You don't get to pick who you work with. So let's say we're a user of toluene, but ExxonMobil is the main importer of toluene. They're going to be the head of the CEIF, and we'll be assigned to work on the CEIF with them and share information. They want information sharing because they want as little animal testing as possible.
Right.
I also mentioned that.
Right. So
it's going to be wild.
Yeah, absolutely. You can see how this is spreading out and tentacles are going everywhere. And yes, it's going to be a fascinating experiment. But in the end, you have to recognize they're expecting there's going to be savings of research dollars. There's going to be leveraging of information and improvement of that information over time. So don't lose sight of that. There's going to be a lot of angst and aggravation in the short term, though, isn't there, Chuck? And job security. Somebody already mentioned that. Yes.
My question has to do with how much strife and unhappiness is there in the EU about this? Because they're no more one big happy family than we are. I mean, Germany doesn't like it or England likes it. They can't all possibly be happy with this, are they?
From what I understand, no. Industry in Europe fought long and hard against it. Anybody want to comment on that with European connections? I've already heard some comments last night over beer, I think it was. No, I mean, obviously in Europe they're not embracing this wholeheartedly, but the European Union has grabbed the bull by the horns and said, look, those that benefit from the manufacture and sale and use of these chemicals should be the ones that develop the information, both on health effects, control, environmental fate, so on and so forth. Now you've seen how the other side of it, whenever it's the government and taxpayer that has to develop the information, how far that's gotten us here in the United States. Everything is log jammed in courts. The OSHA regulations are not flexible enough to permit the promulgation of new improved exposure limits, and probably never will be. But so we're at in this position where we are not developing any new information. And so, a grand experiment. Any more questions?
I have one question and one comment. A question is on one of the slides you talked about what a substance is, and there was one line in there that says applies to substances that can be released from articles, and when a substance is present above 0.1% by weight. I guess I'm a little confused as to what a substance is, what an article is being released, and do you have an example? You could maybe give me a what is and what is not affected.
Let's go back to my statement where I said I'm not an expert on REACH, but then ignoring that, okay, article is a something, an object. Now you can have maybe residual monomer left in that can be released. And we've heard about phthalates and other things, plasticizers, so on and so forth. So I think that's what they're talking about there. And then the 0.1% is probably some kind of mass percentage cutoff for a particularly toxic compound. Chuck, do you have any insight in that?
There's another category of article with intentional release. And what's a quick? Well, I'll use our example, which isn't very glamorous. A toilet bowl scrubber that releases a bleaching agent. That is an article with intentional release, so that adds to the complexity.
I see. Okay.
I don't remember the cutoffs of chemicals in what we would normally consider to be an article. I haven't memorized the standard that well.
Well, you can go to the website. The website is listed in the presentation. I believe everything is available in something like 18 different languages, people. So that's another component of this.
I just had one comment, too, from being involved. I don't know if you studied the RoHS, the Restriction of Hazardous Substances, which is similar. The EU has a sort of a wide, I can email you a slide of all their directives coming out, and this is just one of many. And you talked about impact and scope and job opportunities and all that. Our company was sort of blindsided by RoHS, and it was just this little directive that came out of Europe, and it has completely transformed the supply chain. And we are even exempt from that, and we are still affected by it. And there's two more coming out, EUP and IPP, which are even more extensive than REACH and these other ones. So I would, for those of you interested in this at all, you talked about it going to be crazy. I mean, if RoHS is any indication, I mean, it is kind of crazy. And you talk about not being an expert. An expert is just someone who simply knows about it because it's so new. So, I mean, I've only...
Everybody in the room now.
Right. I've been studying RoHS for maybe 3 years, and I'm considered an expert, and I just because I know what it is. So don't sell yourself short, I guess.
Well, a good friend of mine is a consultant, and he's working with smaller companies to help them pre-register. First of all, to recognize that they need to pre-register, and then to help walk them through the process. And so, there's people out there that are instant experts because this is so new. Simply even knowing the URL for the website probably makes you an expert.
In the list of exceptions in the scope, first, number one, what is meant by waste? And number two, how did the pharmaceuticals become excluded?
Well, I don't know about that last one. I didn't think that they were excluded. I took that information from one of the websites, some of the preliminary information, and I was told the last time I gave this presentation that pharmaceuticals or active pharmaceutical ingredients were exempted as being covered under other regulations. So I can't verify that. And I think I mentioned I was somewhat uncertain about that at the time. And what was the other one? Hazardous waste? Well, it's probably referring to hazardous waste being covered by other regulations. The active pharmaceutical ingredients are not. Okay, so there we go. So once it's a tablet or or whatever, it's exempt, but all the ingredients, therefore the manufacturer of the ingredients and the ingredients that go into the manufacture of the ingredients are covered. There was another comment? Chuck?
I'd like to comment on connect the dots on a couple of topics. One of them was the AIHA strategy and REACH. Well, largely because of Perry, saturated Europe with our exposure assessment, we already have the data that we need on our workers. So if there's a process that we need to look at that's under our roof in manufacturing, we have an exposure assessment on it, and we don't have to model that. And that's a great luxury that we have. So if you've done the AIHA strategy, if you have that data, you're in good shape for your workers. That doesn't answer, of course, our downstream users. We still have to do modeling for them. But we have an embarrassment of riches on our own employees. In fact, we have so much data that I have to bring it up and summarize it because I can't report that much. I can't report task by task data. They want an overview of the process, and we have it. Yeah. But that's because Perry went in there with a whip and a chair and got them all to do their exposure assessments.
Well, there does seem to be this reliance upon modeling both for the toxicology assessments and also for exposure assessments. And, modeling without validation is perhaps a little better than a guess. I hope Rom doesn't disagree with me too much on that. But, there should be validation of these models if you're going to use them for predicting exposures in all these various use scenarios. Any other questions? Now, this is going to be fun to watch, people. I hope you're going to be in the field for the next couple decades because I think this is going to be fascinating.